Hello everybody, this is Aly Ibrahim on behalf of myself and Dr. Sharif Abdel Mohsen, Dr. Walid Omar and Dr. Sharif Ibrahim. I will present a research paper entitled Moisture Harvesting Lizard Skins as an inspiration for performative building envelopes in arid climates. The research will focus on shape-shifting adaptive architecture skins based on bio-inspired programmable materials. The paper also will investigate the moisture harvesting lizard skins, especially Trapezus, who is located in northeast of Africa. Utilizing digital fabrication techniques can improve the durability and morphological capabilities of the programmable materials based on surface formation and aggregation. Multiple physical experiments were conducted on different samples of wood under different humidity conditions. Samples are 3D printed wood of single layer, textured pattern samples, and a sample with potassium chloride included. The paper also will exhibit the importance of achieving the highest moisture retention to be used as an adaptive building skins in arid climates through various design possibilities for performative building envelopes. Specifically in arid climates, lizards have unique physical properties to improve their ability to absorb water. The microstructure of their skin also featuring tubes between irregular overlapping patterns. These patterns can passively and directly transfer the collected water. Lizard also has the ability to increase waterability. It frequently occurs due to their specific features of their microstructures. The water enters contact with fragmented surfaces, so the geometrical configuration is very important to enhance the skin to uptake more moisture. That's why water fills the inner surfaces of the semitubular channels as capillary. The greater surface area, the greater interaction between the surface and water. In terms of wetting, as shown in this figure, depending on the surface structure and roughness, each liquid-material interaction leads to a different wetting phenomenon. Chemical composites and components are applied to catalyze the process of humidity retention to improve the material moisture absorption capability. Potassium chloride as a chemical composite can also retain moisture for a long duration. Based on mimicking the microstructure and moisture harvesting properties of lizard skins, potassium chloride is embedded in the 3D printed samples to test the hygroscopic properties of the composite. Under different humidity conditions, the hygroscopic wood materials have been experimented. The three samples were tested in a humidity chamber, which consisted of a humidifier and a dehumidifier to apply in very specific humidity conditions throughout the experiment. The experiment started off by designing the 3D samples using Rhino and Grasshopper 3D, utilizing the multiple considerations were developed based on the 3D patterns inspired by the lizard skins, and after that utilizing digital fabrication techniques for producing these wood samples using 3D printers. After each stage of the experiment, Kenovia software also used to measure the deflection angle of these samples, and the samples are 3D printed samples, 3D printed samples with mimicked pattern, and 3D printed sample with mimicked pattern and potassium chloride composite. In the first stage of the experiment, the samples reacted gradually to room humidity by angle of deflection 3 degrees, but after 1 hour, while increasing the humidity to 83, the angles of deflection gradually increased for each of the samples, and the second sample records the highest angle of deflection. After finalizing the experiment and observing the samples for a total of 5 hours, sample 1 and 2 were shown to return gradually to their initial shape, while sample 3 was shown to react to the humidity absorption by the composite and exhibit the largest angle of deflection, which was 39 degrees. After analyzing rusted that located in desert region in Egypt through annual humidity analysis graph, it shows that an increasing level of humidity at night is more than day hours. This demonstrates that the material can retain humidity at night and influence its morphological ability and transformation during the hot daytime. It was concluded that the paper investigated the ability to improve the durability and morphological capabilities of the programmable materials based on surface creation, surface formation, utilizing digital fabrication techniques as well. One of the aims is to translate the biological formation of lizard skin in arid regions that located in the arid region into geometry and material composition. The process of mimicking morphological complexity and humidity retention in lizard skins was always used also to inform a digital workflow from inspiration stage to fabrication stage. In the experimental part, the research concluded that the material of single plane layer reacts directly to humidity and with minimal ability to retain moisture, while material composed of textures, extrusions, channels, patterns were shown to retain more moisture than the other. It was also shown that utilizing chemical composites like potassium chloride on top of these textured layers was highly significant in moisture retention, giving it an edge in terms of moisture retention in adaptive building envelopes in arid climates. And thank you.